be on Monday. Very similar. Today we're going to work with what's called the irrational root theorem. Does anybody know what it means if a number is irrational? Goes on forever with no pattern. Okay, so this is going to be some nasty decimal. You've seen a bunch of these on the graphs in the last couple of days. Technical definition is it can't be written as a fraction. The word rational means it can be written as a fraction. So like if I had 0.3 repeating, that's the same thing as 1/3. That's a decimal. It goes on forever, but it has a pattern. Irrational numbers are decimals that go on forever with no pattern. Anything that's under a square root that is not a perfect square. I'm going to say if we're taking the square root of something that's not a perfect square, and I'll show you when we do a couple examples here with my calculator, that will be an irrational number. If you take this, like the square root of 7, gross decimal. Square root of 8, gross decimal. Square root of 16, 4, so it's not irrational. So it's the square root of anything that's not a perfect square will be an irrational number. What we're going to do here is just kind of illustrate what we're going to talk about today, which is the irrational root theorem. All our roots that are irrational are going to have a radical in them that is not a perfect square. I'm just going to have us do the quadratic formula on this real quick. And just basic, like you're not going to think, this is not factorable. You cannot think of factors of 9 that add up to -8. So I would think 9 and 1, but that adds up to 10. And then I would think, well, what if I did -9 and +1, but then that doesn't multiply to give you 9. So this is not factorable. All right, so we're just going to do quadratic formula. So I'm going to do opposite of b, which would be +8, plus or minus square root of b, or sorry, square root, and then b squared. Now, if I'm being honest with you, I don't ever worry about whether that's negative or not, because whatever you do to that, you're going to square it, whether it's positive or negative, it's always going to make it positive. So if you want to just put in 8 squared when you do that, it's not going to affect your answer. And -4, excuse me, times 1 times 9. Everybody over 2a, so 2 times 1. You're going to get 8 plus or minus, let's see, we're going to do 64 minus 4 times 9 is 36. So this is going to give me 28, which is not a perfect square. Can anybody tell me what 28 is if you would break it down under a radical? You think? It's 2 root 7. So I'm going to write 8 plus or minus 2 roots of 7 over 2. If you're like, what the heck? 28, the biggest perfect square, or if you want to do a factor tree, either way, but the biggest perfect square that goes into 28 is only 4. 4 times 7, the square root of 4 is 2, so I can remove the perfect square, but the 7 would stay under the square root. Now, if you have a quadratic solution like this, if all three, the two numbers around, don't worry about the radical, don't touch the radical, around the plus or minus and the number on the bottom, if they're all divisible by something, you can reduce that. Who could reduce this one for me? What would you have?
4 plus or minus 1.
Yep. 4 plus or minus 1 roots of 7, like 2 divided by 2 is 1. Typically, I would never take off points, but typically if you would just have a 1 in front of the radical, they might not write that on an answer for an answer key or something like that. Okay, now, 2 answers, right? And I'll just grab my calculator. These are both irrational answers. If we had put this on a graph, it would have been a garbage decimal. Like if I do 4 plus root 7, garbage decimal. 4 minus root 7, different garbage decimal. But they would go on forever with no pattern. If we had graphed this, those are the 2 places the graph would have crossed the x-axis. They're decimals that go on forever with no pattern. Now, just for this question, I'm going to do this because I'm going to try and illustrate what's going on with these questions today. This is 2 different answers, right? This is 4 plus the square root of 7 was one of the answers, and then 4 minus the square root of 7 is also one of the answers. These guys are called conjugates, and we're going to talk about that in 1 second. But just in general, a root or a 0 of a polynomial, if you were to plug this in for x, which would take maybe a second to do on the calculator because I'd have to plug in 4 plus the square root of 7. But if I would plug that in for x, it would make the polynomial equal to 0. If you have number pairs of this format, they're called irrational conjugates. So I'm going to write this like a general form. So it's a plus the square root of b. A and b would be replaced with numbers. B could not be a perfect square. And its conjugate is just a minus the square root of b. So if you look at the format, right, those two things I had written, I had 4 plus root 7, 4 minus root 7, they are identical. The only difference is one has a plus and one has a minus in between. So if one is a root, we're going to talk about this for our theorem here today. Let me just write it as I say it. All right, so if a plus the square root of b is a root or a 0 of your polynomial, then automatically a minus the square root of b, its conjugate, is also. And I could rewrite that theorem, like, you don't need to do this, but if you had a minus the square root of b, that was the root of your polynomial, then a plus b would also be a root. So it works like if I flip that around. So if one is a root, the other is automatically also a root. So the first example, this is not terrible. Literally all you're doing is telling me if you know this is a 0, what else would be a 0? Or if this is a root, what also would be a root? So if I have 2 minus the square root of 5, automatically its conjugate is also a root, which would be 2 plus the square root of 5. If 1 is an answer, automatically its conjugate is also. Basically what that means, if we would have gone through and done the quadratic formula, we would have gotten 2 plus or minus the square root of 5 as we did our quadratic formula. That's what that means. So if they tell you 1, you automatically will have the other one. Okay, now this is a little bit tricky for this. So I have square root of 7. This does have a conjugate, so I'm just going to write it a little bit differently. Let's say I had 0 plus the square root of 7. That would be the same thing as what I have written there. It does have a conjugate. So the conjugate there, that would be the other solution, would be 0 minus the square root of 7. If I was doing this problem, I would just say negative square root of 7 is my other root. Like those two that I just put the box around, those are what I put as my answer. But if it just has a square root, it automatically has a conjugate. So if they give you positive square root of 7, just put a negative in front of it to get its conjugate. In that case, if we had done the quadratic formula and got square root of 7, actually we probably would have done square roots if we don't have two pieces to it. So this would have just been like plus or minus square root of, maybe we had like x squared minus 7 was our factor, and that's what we would have gotten. So that's what it would look like if we did square roots or quadratic formula. Okay, now I have the numbers here for my zeros, 3, negative 3, and 0. Do I have any conjugates there? No. You do. If you do not see a square root or you do not see an I, don't write anything else. In this case, sometimes people get in the habit of this and they start going, oh, okay, so negative 4 and positive 3 here. Don't do that. Just because a number is a root of a polynomial does not mean it's opposite. Those are two totally different things. Conjugates and opposites are totally different things. So nothing, I get no additional roots there. This one is very tricky also. So I'm going to pull this back down just for a second. So I did the quadratic formula here, right? I got 4 plus or minus the square root of 7. Let's just say for a second we had negative 4 here. So like negative 4 plus or minus the square root of 7. That's kind of the same concept here, and I think that screws people up to do a conjugate. So you have negative 3 plus the square root of 11. You do not change the sign in front of that number. So this would be negative 3 square root 11 would automatically also be a root. Basically what would have happened, that's my answer, what would have happened there if we did quadratic formula, we would have gotten negative 3 plus or minus the square root of 11. Sometimes when we write conjugates, people think they have to change all the signs. Don't do that. You're just going to change the sign in the middle between the two terms. Don't change anything else. the negative square root 29. If you have a square root, you automatically, unless it was a perfect square, you automatically have a conjugate. So if this is negative square root 29, it would be also automatically positive square root of 29 would be an additional root. That would have probably been a situation where we did square roots and we got plus or minus square root of 29 as our answer. And 29 doesn't break down under square root.
Can we just not put the plus sign in front of the square root 29?
Yeah, you can just put, yes, for sure. For sure. I'm just, yeah, if you want to just write square root 29, that's completely correct. You don't have to put a plus. I'm just trying to show you I'm switching up the sign. Now, on the very last one, 16, you won't get anything from 16. So don't be like, oh, 16 is an answer, so negative 16. It doesn't work like that. Not for plain numbers, only for radicals. So the only other root here, I'd have 4 plus the square root of 2. So I'm just writing any additional roots. So you're only going to get additional roots if you have a square root. Or we're going to work with this next week. If you have an I, then you can have an additional root. Is anybody having a question? Okay, now, once you have that down, we're going to write some polynomials from the given roots. So here's this first question. Write the polynomial function in standard form. So we're going to multiply this out. We're going to start with factored form with the given roots. So it says 9 and negative square root of 3. Okay, based on what we just talked about, do I have any additional roots to this polynomial that are not listed in the problem? Hunter, what do you think? Plus square root of 3. You can just write square root of 3. You could put a positive sign in front of it, whatever. Don't put negative 9 because it's only for a square root that you get an additional root. So I really have 3 here. Okay, so I'm just going to set this up in factored form. Since I have the roots, let me just write the factors. So if 9 is an answer, what would be the little linear factor that would go with that? Like x minus 9, exactly. All right, what about negative square root of 3? How would I write that like in a factor? What would that look like? Riley, what do you think? She's going to have to learn sign language today. X plus the square root of 3. There you go. I could hear that. All right, what if I have a positive square root of 3 as my 0? Hunter, what do you think? Same thing but negative. Exactly. X minus the square root of 3. Okay, now, we did a little bit with this a couple days ago, but I'm just going to remind you. If you have to multiply this out, what we have right here is factored form, and the question says, I want standard form. So if you have factored form, you want standard form. You can multiply these in any order you want, do 2 at a time. However, what I would tell you, please multiply together the factors with the conjugates, because if you do those first, all the radicals, all the square roots will cancel out. All right, so if you have conjugates, like I have here, you could do like x minus 9 times x plus the square root of 3. You're going to work with a bunch of radicals, and then you're going to multiply that by x minus the square root of 3, and that's going to take you forever. If you multiply these guys together first, it does kind of work like a difference of squares. They're exactly the same, but one's a plus and one's a minus, so all the radicals will cancel out. So let me just go, I'll just do it real quick like a little foil. So x times x would give you x squared. Then I'm going to do x times that negative square root of 3. Typically what you do there, if you have a number or a variable times a square root, you put the number or variable, in this case, in front of the square root, so that way we don't confuse it and think it's underneath the square root. So that would be x minus radical 3. You can always multiply. We can only add or subtract if we have like radicals, though. Now, in between here, sorry, I should have put my little foil here, what I'm doing. Square root of 3 times x, what you do is you turn around and you get positive x times the square root of 3. Those two terms are going to go. Now, the term on the end is always negative because you have one of each. One's positive, one's negative when you're working with conjugates. So if I multiply positive square root of 3 times negative square root of 3, the negative is not underneath. It's out in front. It's like a positive 1 times a negative 1 out in front. What would you write for square root of 3 times square root of 3? What would it become? Square root of what? 9. multiply the numbers. Don't put, like somebody last period told me 6. Don't do that. 3 times 3 is 9. Now the deal is that will always create a perfect square when you multiply a square root by itself. So here I have x squared. What's the square root of 9? 3. So this, all the radicals are gone. Now I still haven't used the other 0 they gave me, which was 9, so I got to use linear factors. So don't forget to bring that down, but multiply the conjugates together first. And then I'm just going to do a little FOIL again. And sometimes, and this is a good example of this, when I FOIL this, it's not going to be in standard form if I just do like x times x squared times -3. So you might have to switch some terms around, but that's probably the worst thing that you would have to do. This would be x times x squared would be x cubed. X times -3 would be -3x. I have -9 times x squared, so it would be -9x squared. So I'm going to have to switch those two terms. And then -9 times -3 is +27. So just to write my answer properly, I'm just going to put that -9x squared and then the -3x after that. So that's in standard form. But so basically, yesterday I was giving you a polynomial that looked like that. Then you were graphing it. You would have gotten 9 from the graph and broken it down. We're going backwards today. I'm giving you the answers and you're writing me the polynomial. Is anybody having a question? Sorry, I should put a 0 in front of that. Nobody has any question. Okay, now, don't get angry with me on the back. These are a little bit more complicated, but I'm going to teach you a little cheat, okay? So, this says write the polynomial function in standard form with the given root. So it says 5 plus the square root of 6. Based on the irrational root theorem we talked about on the front, do I have any other roots besides 5 plus radical 6? 5 minus radical 6. Okay. So 5 minus radical 6. Basically what this means, I just have two answers, right? So if we do the quadratic formula, we would have gotten 5 plus or minus the square root of 6 as our answer. All right, both of these are irrational. What I would tell you here, this is weird, but it's not just like a 5 where I can go x minus 5, or it's not a -3 where I can go x plus 3, because I got a couple terms here. Here's what I want you to do. Anytime you got a couple pieces to your 0 here, like this, just do x minus. Never do a plus, just do x minus every time. And then what I'm going to do, sorry, I should set that equal to 0. I'm going to put this in parentheses. And it doesn't matter, either one, first or second, doesn't matter. Just copy that irrational number. So I'm going to do a 5 plus radical 6. This will have 3 pieces to it. Every time do a minus. Do x minus. The other 0 is the conjugate 5 minus the square root of 6. And it doesn't matter which one you do first or second, but always do x minus. Now I just want you to think about this for a second. If I took 5 plus radical 6 and plugged it in for x, right, I would have 5 plus radical 6 minus 5 plus radical 6, and that would become 0. That's why it works like that. If I put this one in here, I'd have 5 minus radical 6 minus, in parentheses, that exact same thing, 5 minus radical 6, so that would make it 0. That's why if you put a minus every time, it will work. Now, before we FOIL this out, here's what I would have you do. Just get rid of the extra set of parentheses inside here real quick. And to do that, I'm just going to multiply the terms inside there by a little -1, because that's what that subtraction sign would do. This is a little more complicated than what you guys are used to, because we're going to have 3 terms here. So it would be x minus 5 minus the square root of 6. The other one would be x minus 5 again, but then plus, because you're going to have a negative times a negative, square root of 6. Now, if you want to do kind of like a modified FOIL, like a FOIL on steroids, it would be triple distributive property. X times everything, -5 times everything, and negative square root of 6 times everything. What I do always on these questions is I draw myself a box. I've got 3 terms and 3 terms, even if you don't like to do a box. And I'm going to show you why I do a box in a second here. So I'm just going to draw like 3 rows, 3 columns for my box. And I secretly love doing these problems. So not secretly, because I just told you. But anyway, I'm going to write down, it doesn't matter which one, I'm just going to write down the x minus 5 minus radical 6 down the side, and I'm going to write the x minus 5 plus radical 6 across the top. All right, now, just like on the front, when I told you to multiply the conjugates together and all the radicals will cancel out, that is true here too. If you multiply these together, all the square roots will cancel out. So I'm going to run through and I'll do the full box and then I'll tell you how I cheat. So x times x is x squared. X times negative 5 is negative 5x. X times the square root of 6, we would just put the x in front of a square root of 6. Then I'm going to go through and multiply everybody by negative 5. So we'd have negative 5x. Now in the middle, you'll always have a plain number. This is negative 5 times negative 5, so it's positive 25. That number in the middle shall always be a positive number. And then I'd have negative 5 times the square root of 6, so I'd just write negative 5 roots of 6. And then on the very bottom line, I'm going to do, this would be x times negative square root of 6, so I'd do negative x out in front, and then a square root of 6. Negative square root of 6 times negative 5 is positive 5 roots of 6. And then down here in the corner, not under the square root, in front of the square root, you have a negative square root of 6 times a positive square root of 6. 6 times 6 would go under the radical, which is going to be a 36. What is that bottom corner box really equal to? Hunter, what do you think? Negative 6. Okay, now, here's what I'm going to show you. These 4 boxes and this box that we simplified down in the corner, those are only the ones that you need to worry about because all the other ones are going to cancel out. So if you look at this, and this is true for what we're going to do on our next lesson as well, I don't even fill in like these 4 parts of that box because I know they're going to cancel out. So if you look back at this, right, I have x radical 6 in this upper right corner, and then in the bottom left, I have negative x radical 6. So those two cancel each other out. Here I have negative 5 roots of 6. Here I have positive 5 roots of 6. So those two cancel each other out. So really when I do these problems, the reason I draw this box, I only fill in like these 4 and this one because I always know that those are going to cancel out. So if you want to not fill those in on your homework or notes or whatever, that is totally fine with me. I do need to combine some like terms to actually write my answer, but it's only going to be these 4 in the upper left corner, and that one box in the bottom right corner is going to be the whole thing for your polynomial. So this solution here, we'd have x squared. Now, these two guys are usually the same, so they don't cancel each other out. So negative 5x and negative 5x is negative 10x. And then what you're going to need to combine for your numbers, the 25 in the middle, and then that negative 6 in the bottom right corner. So that would be 19. This is the polynomial, quadratic equation in this case, that has the solution 5 plus or minus the square root of 6. So if you did quadratic formula on this, the result would be 5 plus or minus the square root of 6. We're just working backwards from the given solutions. Does anybody have a question? Okay, so do it right here. 25 minus 6. So it's the two numbers will be right in the middle and right in the bottom corner. And they're always in the same position if you set it up this way. So then you'll know, like where I've got my little purple highlighter, those 4 boxes, like I literally don't even fill them in when I do these problems. And you don't have to either if you don't want to. Okay, now we're going to do one more. This one's a little more complicated, sorry, because it has an additional it doesn't just have that irrational number like the last question did. So I have negative 8. Do not write positive 8. I'm going to write x plus 8 as my factor, but negative 8 doesn't have a conjugate. It doesn't have a square root, so it doesn't have a conjugate. The one next to this is tricky. Don't forget what I told you on the front. Do not change where that says negative 2. Do not change the negative 2. That stays the same. You're just going to change the sign in the middle to get the additional root, which would be the conjugate there. What this means, we're going to get a quadratic in a second. If we had done the quadratic formula on it, we'd get negative 2 plus or minus the square root of 13 if we were solving it the other direction. We're just working with the solutions today. All right, I promise you, every time, just do x minus, and then put whatever those two pieces are in parentheses. So one of them was negative 2 plus the square root of 13. And then I'm going to do x minus, the additional root is negative 2 minus the square root of 13. Always do a minus. If you actually plug in the 0 they give you, it would cancel out the set of parentheses. Here, if you did the first one, here if you did the second one, and it would make the parentheses 0. The only thing I would tell you again, just before you try to start multiplying anything, just get rid of that extra set of parentheses by distributing a little negative 1. So this guy's going to stay x plus 8. Then I'm going to have minus a negative turning into x plus 2. Negative times a positive minus the square root of 13. The other one, you'd have x minus the negative is going to turn into plus 2. And a negative times a negative, we're going to have plus the square root of 13. Like I was telling you in the front, if you have, you can multiply these in any order, but please save yourself some time. If you have conjugates, just do those together first. And if you want to do a FOIL, do that. If you like this box in any way, shape, or form, it's one of my secret favorite things to do, is just work with these. I'm going to just draw like a little 3x3 box. And I'll write it in on this problem, but I just automatically know all 4 of those are going to cancel each other out. So if you want to just leave those blank, you can totally do that. I'm going to do x plus 2 minus the square root of 13 down the side, and x plus 2 plus the square root of 13 across the top. Here I'm going to get x squared 2x. If you want to write it, you can. This one would be x radical 13. This would be 2x, this would be 4, this one would be 2 radical 13. This guy's going to be negative x radical 13. That one and that one cancel each other out. So if you want to leave it blank, that's fine. And then this one is going to be negative 2 radical 13. This one and this one cancel each other out. So if you want to just leave those blank, I'm totally fine with that. The bottom corner is always negative because you have one positive and one negative when you have conjugates. And then 13 times 13 is 169. And so this just results in negative 13 in that bottom box. All the radicals should cancel out. So I promise it's these 4, the upper left, that you need. And then that bottom right, those 5 boxes are the only things that won't cancel out. So you've got, let's see, I'm going to write it underneath here. We've got x, I'm going to write it on the screen so you can see it. X squared, 2x and 2x, these don't cancel. They're both the same, so add them up. So it'd be 4x. And then what we want to grab are plain numbers. You're going to have a number in the middle and a number down here. So we got to combine those. 4 minus 13 would be negative 9. And then forgive. This one also said that 8 or negative 8 was the solution. So I got to go a step farther to get the full polynomial here. That's the hardest part, is multiplying those conjugates together. Now, if you want to draw a box again, feel free. I'm just going to do like a normal FOIL on this. So I'm going to do x times all 3. We're going to get, let's see, x cubed plus 4x squared minus 9x. And then I just stack these up so I can add the like terms easier. I'm going to multiply 8 by everybody. So then we're going to get 8x squared. I just line that up with the 4x squared. 8 times 4x is 32x, and 8 times negative 9 is negative 72. This is x cubed plus 12x squared plus 23x, and then minus 72. I'm really sorry, you guys. We're really low on time today. But that polynomial would have the solutions we had in the original problem. Is anybody having a question at the moment? Okay, sorry.